Hello everyone. Today, me and my friend Taha Saad
Hello everyone.
will talk about the drilling process and its main problem.
The contents of our presentation are: number 1, the main systems of the rig; number 2, the drilling process; number 3, what we need to drill a well; number 4, the drilling problems and their solutions.
First of all, we'll talk briefly about the main systems of the rig, and they are: the first system is the power system. The power system on a drilling rig provides the power for the other main systems on the rig and other ancillary systems, such as electrical systems, pumps, etc. The second system we have is the hoisting system. The hoisting system on the drilling rig does the heavy lifting on the rig. It's used to raise, lower, and suspend the drill string and lift casing and tubing for installation into the well. The third system is the rotary system. The rotary system is the system that causes the drill bit to rotate at the bottom of the well bore. The fourth system is the circulation system. The circulation system on a drilling rig is the system that allows for circulation of the mud of the drilling fluid or drilling mud down through the hollow drill string and up through the annular space between the drill string and the well bore. The last system is the well control system or the blowout prevention system. The blowout prevention system on a drilling rig is the system that prevents the uncontrolled catastrophic release of high-pressure fluids such as oil, gas, or salt water from subsurface formations.
What we need to drill a well. There is a multiple things you need after you study the area and decide the drilling which they are. Number 1, top drive or Kelly. Number 2, rotary drive or rotary table. We can use it, of course, to rotate the Kelly. Number 3, drilling pipes. We need a number of pipes in order to connect between the surface and the end of the well. Number 4, drilling mud or drilling fluids, which is used in the drilling process to aid the drilling of boreholes into the earth, often used while drilling oil and natural gas wells and on exploration drilling rigs. Drilling fluids are also used for much simpler boreholes, such as water wells. One of the functions of drilling mud is to carry cutting out of the hole. Number 5, pit. The drill pit is an important component in the drill string, and it drills the rock in many mechanisms.
The drilling process. The drilling process is as follows. First, mud or drilling fluid is pumped into the well, and then drill bits start to run. This is done by transmitting torque from the top to the bottom of the well. The drill bit breaks the rocks into smaller and shattered pieces, so the drilling fluid can lift these rocks upward and out to separate them from the drilling fluid, then pump the fluid back in the well. And also the hydrostatic pressure that belongs to the weight of the drilling fluid helps to maintain the balance in the well, as you can see in this animation. And also, as shown, the drilling fluid is extracted from the holes in the drilling bit. This type is known as trichome bits. The cutting structures are mounted on 3 rolling cones, and all these cones are attached to main bit body in order to provide the necessary energy to break the rocks and turning them into smaller pieces.
The last stage of the drilling process is the casing, which is known as a large pipes run and cemented in the place and used to protect the hole and allow the continue of the drilling operation. So, after the drilling process takes place, we need to do what we call it casing for every part. As you can see in this video, the casing process is done by lowering tubes in the wall and fixing them with cement. And there is 4 types of casing, and they are: number 1, the conductor casing; number 2, surface casing; number 3, intermediate casing; number 4, production casing.
The drilling problems. The first problem is sloughing shell. happened when there is no adequate mudway to control subsurface pressure. It causes borehole collapse, then stuck the drill pipe or PHA, which stands for borehole assembly. The swelling shell is the opposite of the previous problem, which is known as the sloughing shell. A swelling shell happened when the sensitive layers like shell contact with the water from the drilling mud. It absorbed the water as a result of that swelling, and probably caused the stuck of the drill string.
The problem of swelling and sloughing shell can be reduced by two ways. The first way, by use oil-based invert mud, help it prevent sloughing and swelling shell problems and decrease the time to reach total depth in several wells, as you can see in this figure. The definition of invert mud is an oil-based drilling fluid that generally consists of diesel oil, with the brine carried as the internal phase in the stable emulsion. This method considered as inexpensive and uneconomical. The second way, by adding calcium compound and some other compounds that reduce sloughing and swelling problems. This method considered as more economical than oil-based.
The third problem is the low circulation zone. The low circulation zone happened as a result of many reasons, and they are: 1. When the hydrostatic pressure is greater than the formation pressure, this will lead to introduce the drilling fluid into the formation. 2. When there are fractions cause the fluid to run into the formation. 3. When drilling an unconsolidated formations that may collapse, leading to low circulation zone. This animation shows you the low circulation zone or low circulation problem.
To solve this problem, special materials can be added to the mud. So these materials could be close the hole or fracture that cause the low circulation zone, as shown in this animation.
Kick and blowout. Kick is happened when the formation pressure is more than the hydrostatic pressure, which causes the formation fluid to enter into the borehole. Blowout is an uncontrolled kick. Happened for the same reason of the kick. The blowout is the worst disaster could happen because it causes loss of lives, loss of rigs, and the damage to the environment.
How to control the kick and blowout? The kick can be controlled by increasing the mud density to be greater than the formation pressure, as shown in this picture. Finally, we hope that you enjoyed this simple presentation.
And also, thank you for your time and thank you for your attention.